Second kind of reaction I want to talk about are acid-base reactions. So, acid-base reactions are one in which a hydrogen ion, look at this here, hydrogen ion, which is H+, is transferred from one chemical species to another. All right. So an acid is the substance that okay. An acid is defined as a substance that dissolves in water to yield hydronium ions, okay? So that's an H2O plus an H plus. Can you see that? And that's because H plus is hydrogen ions actually piggyback on top of a water molecule, right? And they make H3O pluses. So an acid is a substance that's defined as something that dissolves in water to yield hydronium ions. This is one particular definition of acids, but it's the most common one. So HCl, hydrochloric acid, is a strong acid because it goes completely, okay? HCl is a strong acid. This is an acid-base reaction, and can you see how the H plus comes off of here, right? There's an H plus there because when it's gone, it leaves a chloride in its wake. You see that? And H plus is transferred from an HCl molecule to an H2O molecule. All right, so here's a picture of what that might look like. You've got this HCl gas in solution. If you put this HCl gas in solution, you put this gas above the water, it dissolves in the water, and when it does dissolve in the water, the H pluses come off and they make little H3Os. And it's a little difficult to see. There's an H3O plus, okay? And there's a chloride ion right there that's surrounded by water molecules. Can you see that? And so that's exactly what happens. There's my aqueous chloride, is right there. That's my aqueous chloride. Can you see it's aqueous because it's surrounded by water molecules? Right? And there's my H3O plus. Okay? H3O plus. And that's also dissolved in water, right? It's not water. It's like water, but it's not. So it's dissolved in water, and we call it H3O plus. All right? Now, strong acids are defined in the following way. Every HCl molecule that dissolves goes through this. Every one. And so we say a strong acid is an acid that reacts in this fashion completely. Okay, so 6 strong acids are here. HBr, these 3, right, can come straight out the periodic table, right? It's actually chlorine, bromine. Fluorine's above it. HF is not a strong acid. Iodine and astatine is below it. That is not considered a strong acid. It's these 3 that are considered strong acids: nitric acid, sulfuric acid, and perchloric acid, okay? Nitric acid, sulfuric acid, and perchloric acid. Those are the 6 strong acids. There are other, some textbooks will say HC, how do you spell HC? HClO3, which is chloric acid, is pretty strong, and some textbooks will include this in this list of the 6 strong acids. They might say 7 strong acids if you want to call chloric acid to be. And by the way, that's easy enough to remember because you can see it's pretty similar to perchloric acid, right? All right, now weak acids are basically every other acid that is not named in that list of strong acids. Way more compounds behave as weak acids, and they only partially react with water. The large majority of dissolved molecules in a weak acid remain in their original form. Okay, so an example of weak acid, the classic example is acetic acid. And in acetic acid, only a small fraction of the acetic acid lose their proton and become acetate, right? Only a small fraction, and so we use this equilibrium sign. And if I want to indicate only a small fraction, I might draw a little arrow going forward and a big arrow going backward, and that would indicate that really more show up in solution as acetic acid. Only about 1% of acetic acid molecules show up in the ionized form as acetate. Okay, so we use the double arrow in the equation, and that says that means it's partial, and it goes both ways. Okay, so but this is also an acid-base reaction because this is the acid and this is acting as the base. In this case, over here, this is the acid, right? And this is acting as a base, right, in the back reaction. Okay? So here's some examples of some acids that that are found in nature. We have vinegar, which looks like that's the acetic acid. So vinegar is about 1%, no, 5% acetic acid. So here's a bottle of vinegar, and here's your acetic acid. Here's citric acid, right, which shows up in oranges and limes and so on. Okay. Now bases are substances that, when dissolved in water, yield hydroxides. Okay. This is the Arrhenius definition, but it's the most common definition that we're going to deal with. So a base yields, it's actually not the most common, but it's a very common definition. And so we're going to use it here. And defined here, an Arrhenius base is a substance that dissolves in water to yield hydroxide ions. Okay. The most common bases are ionic compounds composed of alkali or alkali earth metals combined with a hydroxide. Right? So sodium hydroxide is by far and away the most common base that we deal with. Potassium hydroxide, and here's a group 2 metal cation, so calcium hydroxide or barium hydroxide. These are the most common bases that we deal with. Now, a strong base is a base that dissolves completely again, right? Just like a strong acid. So if we have a strong base, sodium hydroxide is a strong base, that means that it all goes to sodium and hydroxide dissolved in water. All right, weak bases are ones that do not go completely, and we have, as an example, ammonia is a weak base, and it turns out that weak bases have a prominent presence of the actual base. So we don't have all of the base taking on and becoming ammonium. Okay, this is also an acid-base reaction. Can you see that there's a proton being transferred? It turns out the proton's being transferred in this case from this molecule, right? Water. Okay, and examples of bases are pine sol, Windex, and ammonia, used in a couple different and used in various contexts. Okay, and finally in this conversation we're going to talk about neutralization reactions. If you have an acid and a base together that go 1-to-1, then you're going to end up with a salt and with water, and this is a neutralization reaction. It's a special type of acid-base reaction in which the reactants are acids and bases, and the products themselves are not acids and bases. Okay, so an example might be magnesium hydroxide going together with an acid here, HCl, and it goes to magnesium chloride and water, where magnesium chloride is a salt. So that is a brief introduction to acid-base reactions. We talked about strong acids and weak acids, weak bases and strong bases, and neutralization reactions. So hopefully that's a good start for your study in acid-base reactions.